5 years ago, Adil was thrice as old as Bharat. 10 years later, Adil shall be twice as old as Bharat. To know the present ages of Adil and Bharat, first we have to form the linear equations representing the above information. This is the first question. There are two statements. One is 5 years ago, Adil was thrice as old as Bharat, and second is 10 years later, Adil shall be twice as old as Bharat. Now, for the linear equations, pair of linear equations, we need two variables, and here let the present age of Adil, let it be x, and the present age of Bharat is y. Now, we have to form the linear equation representing the above information. First one is 5 years ago, Adil was thrice as old as Bharat. So 5 years ago, Adil age was x minus 5. This is the age of the Adil, x minus 5. And age of Bharat was y minus 5. And Adil age was thrice as old as Bharat. That means 3 times the age of the Bharat. So we can write this as x minus 5 is equal to 3y minus 15, or x minus 3y plus 10 is equal to 0. This is the first linear equation. Now we have to find the second linear equation, and we will get it from the second statement. That means 10 years later. Now 10 years later, the age of Adil age will be 10 years later, the Adil age will be x plus 10. Similarly, the age of Bharat will be y plus 10, and Adil shall be twice as old as Bharat. That means 2 times as old as Bharat. 2 into y plus 10. Or we can write this as x plus 10 is equal to 2y plus 20, or this implies that x minus 2y minus 10 is equal to 0. Now we got two linear equations which was required in the first part. Second part is we have to show that the system of linear equations is consistent with unique solution. For consistency, if we know that a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0, it is consistent, meaning it is having solution, either single unique solution or infinite number of solution. For unique solution, we have to find a1 by a2 should not be equal to b1 by b2. This is for unique solution. Or for infinite solution, we will write a1 by a2 is equal to b1 by b2 is equal to c1 by c2. This is for unique solution. This is for infinite number of solution. It is for infinite number of solution. Infinite number of solution. This is for unique solution, which actually we need here. This is unique for unique solution. So here, if you compare if you will take this as a1, see, you will take this as a1 minus 1 is a1, minus 3 is b1, and plus 10 is c1. Similarly, either 1 is a2, minus 2 is b2, and c2 is minus 10. So we can write here a1 by a2, that is 1 by 1, is not equal to minus 3 by minus 2. As this equation holds, so it will have a unique solution. So that the system of equation is consistent with unique solution. In case of infinite solution also it is consistent, but question is asking first it is consistent with unique solution. As a1 by a2 is not equal to b1 by b2, so system is consistent with unique solution. Because a1 by a2 is not equal to b1 by b2. This is holding. Now for the third part, we have to solve the pair of linear equations. Find the present ages of Adil and Bharat. That means we have to find out x and y. Two equations are given. Either we will follow the substitution method or we will follow the elimination method. Suppose we will go for elimination method. Now equation 2, I am taking this one as equation 2. You can write here it is 2 equation number 2, and this is equation number 1. So equation 2 you can write x minus 2y minus 10 equal to 0, and equation 1 it is x minus 3y plus 10 equal to 0. So if we subtract it, now if we subtract, we will get, this is minus, this is plus, again minus, so we will get y minus 20 is equal to 0 or y is equal to 20. If y is equal to 20, put the value of y in any one of the equations, then we will get x. Suppose in equation 1, if we put value of y in equation 1, we will get x minus 3 times 20, y is 20, plus 10 equal to 0. This implies x is equal to 60 minus 10, which is equal to 50. So this is the present age of the Adil, 50. This is Adil's age, Adil's present age, and 20 is present age of Bharat. This is the complete solution.